then summation k is equal to 1 to 2 minus 1. 2 by 3 raised to k is equal to minus 3. 2 by 3 raised to 2 plus c. Is that right?
Yes, ma'am.
Here I am substituting n is equal to 2 in this. I want to find value of c. So what is this left hand side now? K is equal to 1 to 1. 2 by 3 raised to k. What is that?
2 by 3 raised 2 by 3.
It is just
2 by 3.
3 minus 3
4 by 9.
by 3 raised to 9. 2 by 3 square. So 4 by 9
9.
and plus c. So what this gives me value? C is equal to what?
2.
C is equal to 2. So therefore this becomes, therefore we get summation k is equal to 1 to n minus 1. 2 by 3 raised to k can be written as 2 minus 3 times 2 by 3 raised to n. That is where n is equal to 2, 3 and so on. Is that okay? So C I got as 2. So 2 minus 3, 2 by 3 raised to n. That is my finite sum. Is that clear?
Yes,
Which is
ma'am.
my finite sum. Now we compute another example 2.8. Compute summation k is equal to 1 to L k square. I want to find finite sum k is equal to 1 to L k square. So for that, we want indefinite sum. So for that, recall what is k to the 1 falling? K to the 1 falling?
K to the 2 falling divided by 2.
No. Just k to the 1 falling. That k to the r falling is what? Or t to the r falling is what? T minus 1, t minus 2 and so on, t minus r plus 1. So what is k to the 1 falling? It is just k.
K.
And what is k to the 2 falling?
K into K minus
K
1.
into
K
K
into
minus
k minus 1. So what can I write? Then k square can be written as k to the 1 falling plus k to the 2 falling, k square minus k plus k. So can I write this k square is equal to k to the 1 falling and k to the 2 falling?
Yes.
Yes. Now if I take summation k square, what will be summation k to the 1 falling plus summation k to the 2 falling? I can write taking summation on both sides. Can I write?
Yes.
Yes, ma'am.
Yes. So what is k to summation k to the 1 falling now? It is k to the 2
K.
K
divided by
falling divided by 2.
plus
2.
k to the 3 falling
K to the
divided by
3 falling divided
3
by
and plus
3.
constant c. Plus constant c because it is indefinite sum. Is that okay? So summation k square is nothing but I can write in terms of k to the 2 falling by 2 plus k to the 3 falling by 3 plus some constant. Now just now we have proved. So what can I? So this 2.7. This is 2.7, right? Theorem 2 from theorem 2.7. Now how can I write k is equal to 1 to L k square? What is its indefinite integral? It is k to the 2 falling by 2 plus k to the 3 falling by 3, right? That is my zk. Now I want to use this. From theorem 2.7 we have. Can I copy like this? From theorem 2.7 we have this one, okay, where Zm is indefinite sum of yn. Is it? So from theorem 2.7 we have this. So what can I write? Summation k is equal to 1 to L. Therefore, summation k is equal to 1 to L. Yk is my k square. Can be written as, how it can be written as? What is my Zn, Zk? Zk is this one, right? This is my Zk na indefinite sum of k square is this k to the 2 falling divided by plus k to the 3 falling divided by 3 and plus c. It is from n to m. N to m म्हणजे m to n म्हणजे 1 to
L minus 1.
L minus
L
1
plus 1.
L
L
plus
plus 1.
इथे
plus 1.
n minus 1 है तो n है. So here L is there, so I have to write here up to L plus 1. Is that okay?
Yes, ma'am.
Yes. So now just calculate now. This, what will be this? L plus 1 to the 2 falling divided by 2 plus L plus 1 to the 3 falling divided by 3 plus C minus 1 to the 2 falling divided by 2 minus, or I can write like this, 1 to the 3 falling divided by 3 plus C. So if I simplify, what I will get?
L plus 1. L into L plus 1.
L into L plus 1 divided by 2.
Divided by 2.
L into L plus 1, L plus
L
2
plus 2.
divided by
Divided
3. This C and C will
plus
get cancelled, right?
minus 0.
Minus, what is
0.
1 to the 2 falling?
0. 0 na ma'am.
Yes, remaining people also to answer. What is 1 to the 2 falling, 1 to the 3 falling?
0.
I have written this. Yeah, that is 0. This I written incorrect, na? T to the 2 falling is what? T to
T
the
into T minus 1.
T into T minus 1. So what should be L plus 1 to the 2 falling? Not L into L
L
plus 1.
plus 1.
L plus 1 केले आणि मग एक एक सबट्रॅक्ट करत जायचं. So Still I am getting that same, but here it will be problem. So I have to start from L plus 1, then I have to subtract L plus 1 minus 1, and then L plus 1 minus 2 divided by
L minus
3. Is that right?
1.
So this
Yes,
is
ma'am.
not correct, or I will write this. Okay, and minus 0. Okay, so I got this one, and if I simplify this, now you can simplify this. L plus 1 to L plus 1 divided by 6. What is this? It is just L into L plus 1, and this is L minus 1. L plus 1, L into L plus 1, you can take it common 3 times, 2 times, then divided by L, you take LCM by 6 will be there, and 2 times L plus 1 you will get. Is that okay?
Yes, ma'am.
So now, so we have computed the definite sum k square from 1 to L. Now we will go to next theorem. Theorem 2.8. What it says, if m is strictly less than n, then summation k is equal to m to n minus 1 ak delta bk is nothing but ak bk m to n minus summation k is equal to m to n minus 1 delta ak bk plus 1. So this is the summation by parts formula for definite sum. It is of that form. We want to prove if m is strictly less than n, then summation k is equal to m to n minus 1 ak delta bk can be written as ak bk m to n minus summation k is equal to m to n minus 1 delta ak and bk plus 1. Okay, we want to prove this now. Now, theorem 2.6 we have proved C. Where is that now? Or I will write. Okay. We know that summation yt delta zt is yt zt minus summation EZT and delta YT. This summation by parts formula from theorem
2.6.
2.6. Yeah. So if I choose yn is equal to n and zn is equal to bn. So choosing yn is equal to an and zn Zn is equal to Bn. We get Yt is nothing but just Yn, right? Because we are treating as a sequence. So here I can substitute it. So what I will get?
Summation
What I
an
will
Summation an delta bn is equal to
summation an delta bn
delta B
delta
an
bn
is equals
bn
is equal to
minus summation delta an b
B of A.
n plus 1. Is that okay? Huh? Yes?
Nothing.
Any problem?
no ma'am.
Here in terms of definite sum we have to prove, but whatever result earlier result for indefinite sum we are having in 2.6c, we are using that here. Okay, so if I choose yn is an and zn is bn, I will get this one. Ezn Ezt is nothing but what? Z at t plus 1 na? So z at t plus 1 will be what? It is bn plus 1, right?
Yes, ma'am.
Yes. Now from 2.2, from equation 2.2, we have relation between indefinite sum and finite sum.
Yes, ma'am.
Yes.
Yes,
So
ma'am.
this indefinite sum I can write in terms of finite sum as summation k is equal to m to n minus
n
1
minus
ak
yk
delta bk. आता हे याच्यामध्ये this I am writing in terms of this ak delta bk, whatever yk you are, ak delta bk is equal to n bn minus summation k is equal to m to n minus 1 delta k bk plus 1 and plus c. Is that okay? Definite sum I can write in terms of indefinite sum, and indefinite
yes
sum I can write in terms of definite sum. So this I can write plus c, but that plus c I have taken here only. Here also plus c, but for this and this I am having only one arbitrary constant. Whatever may be c plus c minus d or whatever, I am treating as only one arbitrary constant plus c. Is that okay?
Yes, ma'am.
And bn as it is. This indefinite sum again I am writing in terms of definite sum. Okay. Now I want to find this c. Now to find c, to evaluate c, put n is equal to m plus 1. What we get? If I substitute here n is equal to m plus 1, what I will get? K is equal to m to m, m plus 1 minus m, ak delta bk is am plus 1 bm plus 1 minus summation k is equal to m2. What will be here again? Delta ak bk plus 1 and plus c. Is that okay? I am substituting in this equation. I am substituting n is equal to m plus 1 so that I can find the value of c. I want to find the value of arbitrary constant c. Is that okay?
Yes, ma'am.
Yes. So what I will get? M plus 1 minus 1. So this summation is only from m to m, means only m the term will be surviving from whole summation, right?
Yes, ma'am.
yes
What will
ma'am.
be that? Am
an delta bn
Delta PM. equals
am
to
plus 1 bm
plus
plus 1
bm plus 1
minus what will be here? Here also one term will survive. Delta
delta am bm plus 1
delta a delta b
Okay.
bm plus 1
1
C.
plus.
plus
So if I simplify, what is delta bm?
bm
Am
plus 1 minus
minus bm. So am plus 1 bm plus 1 minus what is delta am? Am plus
am
1
plus 1
minus
theorem.
am bm plus 1 and plus c. So you can see, or I will write am bm plus 1 minus am bm, which is equal to am plus 1 bm plus 1 minus am plus 1 bm plus 1 plus am bm plus 1 and plus c. Is that okay? Just simplifying. Now you can see am plus 1 bm plus 1. This will get cancelled with this. Uh, no, this will cancel
Plus
with
1.
am bm plus 1. And this am plus 1 bm plus 1 am plus 1 bm plus 1. Okay, these two terms are same and these two terms are same. Is it okay? So what I am getting? C is nothing but
C
just
is equal to minus A
am
bm.
m the term am bm. So what I am getting? So here I am getting minus am bm, right?
Yes.
So, therefore I will write this star, or therefore star becomes k is equal to m to n minus 1, no? Or I will copy and paste it. Okay, I will write it again. Summation is that k is equal to m to n minus 1, no?
Yes, ma'am.
n
AK
minus
delta BK.
ak delta
BK
bk n
is equal
minus
to
n
N
bn,
minus
no?
A and BM minus
Minus summation k
summation
is
K
equal to
rest
m
from
to n
M to
minus
N 1
delta
delta
k
into BK plus 1
k plus 1 and plus c is my am
minus A BM.
bn, right? So this I can write as an bn minus am bm minus summation k is equal to m to n minus 1 delta ak bk plus 1. So k is equal to m to n minus 1 ak delta bk, and this I can write as ak bk
M2N.
M2 and delta AK BK plus 1. That only we want to prove. So this is summation by parts formula for definite sums. Is that okay?
Yes, ma'am.
Yes, ma'am.
Summation by parts formula for definite sums. Okay, so using this we have to solve some examples, but that we will do it tomorrow. Okay, so at present 2 theorems, 2 examples we have seen, right? So today we have seen 2 theorems and 2 examples, and based on this new summation by parts formula for definite sums, we will see examples tomorrow. Is that okay? Today's lecture?
Yes, ma'am.